Hello and welcome back. Today, not on the bench, however, in the lab, is my DSA 602A. During the 475 videos, which are, it's another problem with it has cropped up. There's some issues with the 8-volt rail on it that I need to resolve. I wanted to use the 11A33 to do some of the differential measurements for the calibration on the 475, but my DSA started acting up. So there's a known issue with the boards in this DSA. The RAM on the acquisition boards needs to be soldered better. They didn't get enough solder during the manufacturing process. Pretty sure that has not been done on this unit yet, so I'm going to open this up. We're going to dig out the boards. Hopefully that's the only thing that's wrong with this. This scope is very microprocessor controlled, so troubleshooting this guy would be a challenge, to say the least. I've got the compressor charging in the garage because we're going to do this under nitrogen, just because we can. And yeah, let's get into it. I want to ground my mat. Normally I don't work with the anti-static mat grounded. However, I do want to do that right now, so I'm going to go get a wrist strap. There's a lot of sensitive ICs and things like that in there, and a lot of irreplaceable components. So I don't want to take any chances with static or anything. I've got a humidifier running, and but I'm gonna use a wrist strap for this one. Now that I have the mat grounded and myself appropriately grounded, we can start by lifting the lid. I also had to unbury this because this particular unit sits underneath my spectrum analyzer, so I had to get under here. Okay, which board is which now? I see some high-speed hybrids over here, but I got a lot of ICs over here. And what I'm really interested in is the RAM section. Okay, so this rear board back here, apologies for the angle, it's kind of tight. This rear board back here is the one of interest. This is the acquisition board. I'm assuming this is the RAM that I need to work on, but then there's an upper acquisition board and a lower acquisition board. So the front of this is supposed to tilt up somehow. I might be on the wrong side for that to get at the lower acquisition board. So let me dig into a manual. We'll see what's going on. Well, this thing in the service position is absolutely huge. So there's a prop rod here. I'll move the camera around. The boards I need to get to are here, and then there's one back here. This is the upper acquisition, lower acquisition board. I need to get those both out, and we'll need to service them, but I also need to get to the underside. While I'm in here and I have the boards out, there's a couple of electrolytic caps that I'll probably replace just for good measure, since we're here. And then we'll go from there. There's a lot of cables that I need to signal cables coming up. These blue guys that'll need to get back in the appropriate positions. So we will do that. Let me show you the other side. Here's the lower acquisition board. Here are the fans. I'm going to clean these while I'm in here. These are actually still spinning perfectly, so not a problem. Here's some of the microprocessing stuff down here. Big, fat ribbon cables that I have to be careful of where they go and get them back in the right place. But here's the prop rod. I was talking about, but got to get the acquisition boards out and then go from there. Chonking heat sinks on some of this stuff. These generate quite a bit of heat. They are very high-speed chips, so that is not surprising. I'm going to double check, but I think these are the SRAMs, and we will go from there. Okay, so confirming through the chip number, these are the SRAMs. Each chip is a 1024-bit SRAMs, but they are high-speed EL logic, so they are very static sensitive. So, well, next thing we got to do is we got to get this board out because we know it's busted. So it's a matter of making it right now because it does have a thermal problem in the acquisition board. So I'm going to snap some pictures, and then I will we'll work on getting this thing, getting at least one of these boards out, and then we'll work on the other one. Well, that pile of screws and those two hybrids later, and I have the boards out. Actually, there's even more. There is even more screws. I did have to take the waveform processor board out to make getting the acquisition boards out easier, but these boards are very large, and they are they have some very delicate parts on it. So decisions to use a static strap are very good and worthwhile, especially with the amount of unobtainium that's in here. Okay, I do not know how well the camera is going to pick this up, but this pin right here is a very good example of the fault that's in here. The power pins of these SRAMs just did not get enough solder, which causes a crappy connection. Now, what I'm going to do, so I don't overheat the SRAM, I have to resolder all the data pins on the SRAM. I'm going to bounce back and forth. So I'll do like one here, and then I'll just bounce back and forth between chips until I get all the pins done. But this is what I had to tear apart to fix, was the lack of solder on the power pins. So obviously mine has the fault, so hopefully that's all that's wrong with it, and I get it back together without incident. Wow, that was a teardown. There's a lot to this one. I have some other things I'm going to do to these two boards while they're out. The thermal grease is pretty old, so when I get to that point, I'll flip the board over. We'll pull off one or two of the heat sinks, put a little thermal grease on there, make sure, refresh that a bit to keep these chips cold, and then hopefully we put it all back together and we don't have any faults. Okay, I'm about half done soldering this section of the board. I found the best technique is to do the wide side of the chip, top, and then you just kind of stair step down a line. I did the bottom section first, the top section, so I'm halfway done. I've done the bottom, done the top. I'm going to flip the board over because that'll let me come in on these side of the ICs and get this. So I'm working inside the chip as opposed to fighting with these pull-up resistors on this side. So spin the board, do the exact same thing on the other side. Didn't realize I've been at this for that long, but I guess I have. Yeah, it's just cranking through it. So I will bring you guys back when I am finished with this side of the board. All right, there we go. There's the soldering iron, or the roll of solder. It feels like I used an absolute ton of solder getting these back up, but when you look at the roll, it doesn't look like it. But there was a lot when I got into it and actually looked at the joints and things like that. There was a lot that was dry, so this definitely needed doing. So what we will do now is I'm going to clean all the flux off and move to the lower board. This is the upper board I just got finished with. And then we'll go from there. I think I'm going to fire, given what time it is, I think I'm going to fire the scope up first before I do the heat sinks. And then just let it sit and cook for a while, because I can get at these heat sinks without having to remove these boards again. Redoing the thermal paste on the heat sinks won't be that huge a deal in the future. But I'm going to clean these up now and then move on to the next board. Here's just another look at one of these power pins. See how dry it is on that solder joint right on this corner. And that seems to be the case with most of these. So, on to the next board. Okay, I've got the upper board done. And it is a, it also took quite a bit of solder on those, the SD, or the SRAM modules. I did make a mistake over here when I took those hybrids off the board. These two connections here means the hybrids don't have to come off. So I'm going to put them back in before we put everything together. So it's these, so these two have to come off, these two don't. So the hybrids will hold themselves in. So I'm going to do that before we get it back in the case. And we'll go from there. These also don't need to come out, so you don't have to mess with these ceramic hybrids. Not having to mess with hybrids is always good. They are very fragile. So let me get these reattached to the board, and then we'll see what's next. These are the hybrids you have to take out, or I mean, this is the way they should look. Stepped should be towards the SRAMs. The key is also here. And then these two, they also should not move. They should lock in. So do not take those out if you don't have to. Well, as with anything electronic, the proof is in the doing. You guys are here for the first power up. Powering up something after this much work is always kind of nerve-wracking. But let's see what happens. Nothing exploded. Self-test, we have display. Let's see. It wants to show me a trace. Sweet. Well, we'll see if it'll do an enhanced alignment. I'm going to power this off. This unit is very, very thermally heavy. It runs really hot. So I'm going to put the top cover back on, and then I'm going to fire up something on the bench to throw some signal on it and see what we get. Okay, we're going to run all the extended diagnostics and see what happens. If it's going to error, it's going to error here. Hey, pass the acquisition boards. That is a clean and green across the board. So I'm going to let this warm up. This is going to sit on the bench for a couple of days. Probably feed it a signal most of the day tomorrow. Let it get good and warm. Make sure we don't have any lingering defects. But This one might be good. We'll make sure it passes extended enhanced accuracy. Once it finishes warming up, should say I need a little bit more time there. Let's see. Exit the diagnostics. Enhanced accuracy. Yeah, it still needs 12 minutes of warm up. So we'll just give it some signal for 12 minutes, make sure it triggers, and then we will go from there. The other thing that's different, that's an improvement, the trigger is stable. Before it was collapsing and coming back, collapsing and coming back, collapsing and coming back. The trigger wasn't consistent, and when the scope got really hot, it would show up as a trigger fault when you tried to run enhanced accuracy. This is staying nice and stable, so because this isn't a hold, this is a run and an acquisition, and I think we should be averaging just continuous acquisition. 250 kilohertz, that's right. Oh, this is where I turn averaging on. Average, yes. Continuous. And so even with 8 averages, it was collapsing and falling out, collapsing and falling out. So this appears to be running. That was a substantial amount of work. I think I spent about 3 hours with a soldering iron in my hand and didn't stop. So that was a substantial amount of work, but getting the scope back, especially because this is my 1 gigahertz scope in a lab, was worth it. So cautiously optimistic. Well, that is always a good sign. So nothing left now but to let it cook, and we're just going to let it crank. So I'll throw some signal back in it right now, and we'll just let it crank and see how it goes. Well, the thermal grease has gotten a bit crusty over the years, so I'm going to add a little bit more. The heat sinks on this are not what I would consider high pressure. They move around a bit. They are spring loaded, so the tension is easy to set, but I'm going to put just a touch more thermal grease on them. Touch up the thermal grease on the pads for the heat sinks, and then we'll fire it up again. And for thermal grease, we're just going to use the normal white thermal grease, non-conductive, nothing special. Okay, while running through this board, something that's important to note is these two are dry. There's no thermal grease on those. Never was. So I'm going to leave them dry. I've got these two done, the top 4 done, this one done. Moving down here, so I got to do this one and these couple coming up the side to finish off the lower acquisition board. And just because working with unobtainium, we are using a strap. Okay, there's 2 more of those dry chips on this side, so these 2 are dry and these 2 are dry. Everything else has been serviced on this side of the board, so I'm going to close it up, do a quick power up, make sure we don't have any problems, and then I'm going to service the top side. Okay, now we're on the top side, and we have less to do up here. So I got these 2 ICs, and then I got these 4 ICs, and then this is done. So these don't need to be worked on. Those hybrids don't need to be worked on. These are obviously dry. So from the top side, though, these are all the SRAMs. These are the solder connections that I had to redo. Yeah, so we'll get these popped off real quick, cleaned up, and then we'll be done. All right, I don't know if I'd call them the main samplers or not, but these 4 chips, which are a decent chunk of the acquisition board, in the short time I had the scope powered on just for a self-test, these got really warm on the heatsink. So that reinforces my decision to re-grease the heatsinks, and also running this limited amount of time with the covers off. These 4 ICs got a little toasty. So everything's all done. I'm going to throw the cover back on, and then we'll fire it up and run it through some testing. Okay, let's run through some diagnostics. While this is running through, difficulty-wise on this one, not awful, nerve-wracking, because if any of the ICs or anything happens to them, troubleshooting and replacement would be a nightmare, if not impossible. However, the other thing that would be of a concern is when resoldering the acquisition boards, just overheating one of those SRAM modules and killing it. Those are pretty sensitive to heat, so good quality soldering iron, work fast, but don't linger on the pins, but also get a good joint. So it's a balance. I did it under the N2 because the N2 helped me out with keeping the board a little warm and keeping the area warm, and I could move back and forth, so it let me have less dwell time on the pin. But it is not required for this repair. Re-greasing the ICs, not bad at all. The posts on the ICs make line up real easy. Everything's good. You do not need to overcrank. Everything passed. You do not need to overcrank the screws. They do not need to be tight because the springs push down on the heatsink to make a good thermal connection. So just hand snug is perfect there. Let me throw some signal up here. I've got that plug in on 50 ohms, so we can do this like so. And just because I can, we'll give it a little bit more signal. And I'm going to let it drive like this for most of the day. Just make sure it doesn't have any errors or anything like that. I'm also not seeing any sampling errors, so I think that fault's been running around in here for quite some time, but has just kind of flown under the radar till I really tried to use the 11A33, and then it kind of got irritated. Essentially, it was a dead bit. When it was polling one of those SRAM modules, it wasn't getting the data it was supposed to, so that was kind of pissing it off. But other than that, as always, I will be in the comments. Thanks for stopping by, and more is always on the way. See everybody in the next video.